For this question, I want you to answer in a full sentence. Why? Because if you just simply say, the answer is this, okay, you didn't actually tell anybody what to go into the lab and do. Imagine you're telling a freshman what to do when they go into lab. You need to use a complete sentence. You need to tell them what glassware to grab. That's what this type of question is asking you to do. So in this case, we're starting out with copper 2 chloride, but it's going to be dihydrate. So don't forget, dihydrate means it's got 2 water molecules coming off of it. So it looks like this: copper chloride dot 2H2O. And because of that, it has a molar mass of 170.4816 grams per mole. That's crucial. If you use the mass without the water attached, your answer is wrong. So what is this asking us to do? It's asking us to find out how many grams of copper 2 chloride dihydrate we're going to use in 500 milliliters or 0.500 liters to make 100 parts per million copper ion solution. And so if you've never seen parts per million before, it's just milligrams per liter of solution, or you can also do milligrams per kilogram of solution. Notice that bottom part is solution, not just solvent. So that's why you typically do those in like a volumetric flask, because in a volumetric flask, you're filling up to the line. So that means this is part of the solution and the water that you added is part of the solution, so your total volume is known. And so here we've got 500 milliliters total solution volume, or 0.500 liters. So what are we gonna do? Let's just start doing conversions. So we need to go from grams to moles. So 1 mole of copper 2 chloride dihydrate is equal to 170.4816 grams. Now, how many copper ions are in copper chloride? It's 1 to 1, so I didn't make that too hard on you. Meaning 1 mole of copper chloride dihydrate, you have 1 mole of copper ion. So that's not too hard, okay? Then, but you gotta make sure you have it, because whenever it's not 1 to 1, that screws you over, okay? Next, we've got 1 mole of copper weighs how much? And obviously, when you're just losing a couple electrons, you're not changing the mass of the compound or the ion. And so that weighs 63.546 grams. And if we set this whole thing equal to 100 ppm copper 2 ions. But remember, I'll put a little asterisk up here. ppm can be expressed as milligrams per liter. So I'm actually missing a conversion factor here. Which conversion factor am I missing? Okay, let's check. Grams, grams, moles, 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 grams, liters. I need to convert grams into liters, so how about I just put this over here? Doesn't really matter which side you put it on, because it's gonna cancel anyway. So I'm gonna say 1 gram is equal to 1,000 milligrams. So now my grams are going to cancel with this grams. I'm left with milligrams on top and liters on bottom, which is what I want. And now I can just plug this all into my calculator and solve for x. So if I take 100 times 170 times 0.5 equals, divide that by 63 number, equals, divide that by 1,000, equals, and what do we get? X equals 0.1341 grams of copper 2 chloride dihydrate. And that is my final numerical answer. But now we need to talk about how am I going to tell somebody to go in the lab and do this. So what I might say, just really simple, is place 0.1341 grams of copper 2 chloride dihydrate into a 500 milliliter volumetric flask, and then dilute to the mark or to the line with water, because that's what copper chloride is going to be aqueous. It's going to be dissolved in. And that would be your final answer.